part of the electromagnetism topic, the exam board like to ask you about the applications of electromagnetism, and they'll often use the idea of a moving coil loudspeaker or a moving coil microphone. In other words, loudspeakers and microphones. And what's key about these is that they both show either the generator effect or the motor effect. So loudspeakers show the motor effect, microphones demonstrate an example of the generator effect, or a way to induce a potential difference. So let's look at loudspeakers first. Loudspeakers, like I say, therefore the motor effect, and this is my amazing diagram that we have here. So this is a simple loudspeaker, and we'll see we've got a permanent magnet inside, and we'll see we've got the north pole in the middle and two south poles either end. Now we could extend this question a little bit potentially, and you might be asked to draw field lines on that permanent magnet. Remember, field lines, a bit of revision here, straight lines that mustn't cross, and you're probably expected to do one or two on either side, and then make sure that you've what's missing here is the arrows, and that always goes from north to south like that. So that's how we draw the field lines on this permanent magnet here. But how does this loudspeaker work to demonstrate and show the motor effect? Well, we'll see that we have here an AC current, and you see both of these could be a 4, 5 or potentially 6 mark question, and students tend to find them challenging, but they all follow the same idea, and I'm sure there were some certain keywords that you kept saying during the electromagnetism topic, so it's important that we try and use these now to show our scientific understanding. So we've got a AC supply here, that's alternating current, if you remember. Difference between DC, which is direct current. So if our alternating current, all right, it's going to produce a magnetic field around the coil. So as current goes around here, it's going to produce a magnetic field. Now, this is from electromagnetism. It's an electromagnet here. And this is going to interact with the magnetic field from the permanent magnet, our permanent magnetic field from these field lines that we've drawn here. So we have this magnetic field around the coil interacting now with a permanent magnetic field. And then, if you remember, what's important here is that we use Fleming's left hand rule, and your FBI, force, magnetic flux and current, and you'll then be able to know that the key bit here is that it's got a force, we've got a magnetic flux because we've got interacting magnetic fields, and we've got a current, so it's going to generate a force, and that force is movement, and that movement then will cause this cone to vibrate and to move. Now, because this is alternating current, the current is going to switch direction, in which case this cone will move backwards and forwards. So this cone is going to be moving backwards and forwards, and that's going to then produce and interact with the air particles, and then a sound wave will be produced. So that's really key here. So the force will be reversed, and then the coil will go backwards and forwards, and then we can hear this as sound as the particles vibrate and oscillate and move, and that's the sound that we hear. So that's the motor effect. Yeah, the motor effect is that we're generating a force. The generator effect is when we are inducing a potential difference. So if we had a microphone here, and that's what this is here, it is a microphone. Apologies for my lack of artistic skill, but we've got these sound waves here, and as we know that microphones, they need sound waves to work, so we've got these oscillating particles in the air, these amazing sound waves, and they're going to cause this diaphragm here, this part of the microphone, the front part here, to vibrate. All right, so it's going to vibrate, and that's That's key language here. It's going to vibrate, not just move, it's going to vibrate, which then is going to cause this coil here, a wire around the permanent magnet, that is also going to vibrate. So we've got a vibrating diaphragm, we've got a vibrating coil, and we've got around that coil we've got this permanent magnetic field. So we're going to have a moving coil of wire that's vibrating, that's going through a permanent magnetic field, and it's going to cut through those field lines at 90 degrees. It's going to be perpendicular, which means then it's going to induce a potential difference. It will induce a potential difference, and that then would support an electrical signal through the circuit. So that's the difference between the motor effect and the generator effect, and how we can compare that using loudspeakers and microphones. I hope that helps you understand the difference between how a loudspeaker works and a microphone works, and also helps you understand a little bit about the motor effect and the generator effect and the applications of electromagnetism. Good luck.